Assalamu alaikum and welcome back to the second part of forces and equilibrium. In our last lesson, we started from the definition of force and then we had done the expression for the resultant force. You can see on the screen, this was the expression for the resultant force, and then we have seen the expression for the direction of the resultant force. Then we did equilibrium, Lam's theorem, friction, and some important types of friction. And then we had solved some examples related to the concepts we did in our last video. Now we are starting from the next concept, which is inclined plane. You can see an inclined plane which is making angle theta with the horizontal, and let's suppose there is an object of mass m. If mass is m, then weight will be mg. You know about this, and you can see in the diagram that this object will be moving in this direction. So we will be resolving all the components parallel to the movement, which is this direction, and then perpendicular to the movement. So all the forces will be resolved along this direction and perpendicular to this direction. First of all, let's talk about the components of weight. You can see that this is a right angle triangle, and this angle will be 90 minus theta. Now if you rotate this diagram, then we can find the components of weight. I'm going to rotate this diagram like this. Yes, like this. Now you can see that this is basically direction of the movement of this object, and you can also see that weight is making this angle 90 minus theta with the direction of movement. So the parallel component of weight, that will be W cos 90 minus theta. We have done this concept in our first video, that all the parallel components or the horizontal components of any force will be F cos theta, and the vertical components will be F sin theta. So the vertical component of weight will be W sin 90 minus theta. That will be the perpendicular or the vertical component of weight. And you know about this, that cos 90 minus theta will become sin theta. You have done this thing in your O levels. This will become W sin theta, and this will become W cos theta. So you can see that the parallel component of weight is basically W sin theta, or you can also say mg sin theta, and the vertical component will be W cos theta. So in this case, or in the case of inclined plane, the components of weight will be different, because usually the horizontal components are W cos theta or F cos theta, or the force times cos theta, and the vertical component is usually F sin theta. But just in case of an inclined plane, the components of weight will be different, and I have told you the reason that why the parallel component is W sin theta and the perpendicular component is W cos theta. So we can have this diagram like this. This is an inclined plane which is making angle theta with the horizontal. This is the object which has weight W, or you can also say mg. First of all, look at the components of weight. I have just told you that the perpendicular component of weight will be W cos theta, and the parallel component or the horizontal component of weight will be W sin theta. If you see this diagram, you will know about the components of weight. And remember one thing, that the parallel component of weight will be always downward, because the weight of any object will bring any object downward. Now, let's talk about the remaining forces. You know about the normal reaction, which is always perpendicular to the direction of movement. So this will be R, which is the normal reaction. And if you talk about friction, you can have two types of surfaces. In case of a smooth surface, there will be no friction. In your examples or in your questions, if it is written that the surface is smooth, you will take friction 0. But in case of a rough surface, there will be a force of friction. And you know that friction is always opposite to the movement. Let's suppose the object is moving upward. If the object is moving upward, then the friction will be downward, like this. And if the object is coming downward, then friction will be upward. So the friction will always be opposite to the direction of movement. Let's suppose that the object is moving upward. So the friction will be downward. Now you will see all the perpendicular forces and vertical forces. First of all, horizontal forces and vertical forces. First of all, look at the horizontal forces. Let's suppose there is a force. Let's suppose the force is T. Then you can see that if the object is in equilibrium, then all backward forces will be equal to all forward forces. So you can have an expression for the parallel forces, that T will be equal to F plus W sin theta. And in case of perpendicular components, you can have an expression. You can see that you have two perpendicular forces. R is upward and W cos theta, this is downward. Now, you can have two cases for inclined plane. This is case 1. I will explain the case with the help of a diagram. Let's suppose you have an inclined plane which is making angle theta with the horizontal, and this is an object which is moving along this inclined plane, and there is an external force acting upon this object. Let's suppose the external force is T, which is making angle alpha with the horizontal. Now again, we will do same thing. We will resolve all forces parallel to the movement and perpendicular to the movement. First of all, you know about the components of weight. This is the original force of weight, and this is the perpendicular component of weight, which will be W cos theta, and this will be the parallel component of weight, which will be W sin theta. And look at the external force T, which is making angle alpha with the horizontal. If you resolve the components, if you resolve this force T parallel to the movement, the component will be T cos alpha, and the component which is opposite to the direction of movement, which is perpendicular to the direction of movement, that will be T sin alpha. Plus, you will have the normal reaction force, which is always perpendicular to the movement. And let's suppose the object is moving upward, then the force of friction will be downward. So these are all the forces which are either perpendicular to the movement or parallel to the movement. First of all, let's talk about all parallel forces. You can see that in this example or in this diagram, you have three parallel forces. T cos alpha is acting upward, and remaining two forces are acting downwards. So you will have F plus W sine theta. And similarly, if you talk about the perpendicular forces, you have three perpendicular forces. Two perpendicular forces are upward, and one perpendicular force, which is W cos theta, it will be downward. So you can have an equation T sine alpha plus R, that will be equal to W cos theta. So this is case 1 of the inclined plane, and let's talk about case 2 of inclined plane. This is case 2 of the inclined plane, and the difference is that in case 1 you had a pulling force, now you have a pushing force. This force T is pushing this object towards this direction, and again the external force T is making angle alpha with the horizontal. So the only difference between the previous case and this case is the vertical component of the external force. You can see that the horizontal component of this external force will be T cos alpha, but as this force is acting downward, the external force is acting downward, so the vertical component of the external force will be downward. This will be T sine alpha. And the friction you can have in any direction. If the object is moving upward, then the friction will be downward. Let's suppose the object is moving upward, so the force of friction will be downward. So if you talk about the external force, you have two components, T cos alpha and T sine alpha. Now the equation for parallel forces will be T cos alpha, that will be equal to F plus W sine theta. It will remain as it is that you had for previous case. But if you talk about the vertical components, you have T cos alpha and R in upward direction. Sorry, R will be in upward direction, and W cos theta, it will be in the downward direction. So for vertical components, you can have an equation R will be equal to T sine alpha plus W cos theta. So this is case number 2 of inclined plane. Now we will solve some examples and questions regarding these concepts. So far we have done all the concepts related to mechanics 1 for forces and equilibrium. Now we are starting some questions. All right, look at this question of October-November 2011. You have a ring of mass 2 kg and a force of T Newton is pulling this ring upward, and the force is making 30-degree angle with the horizontal, and there is a coefficient of friction between ring and rod which is 0.24. Find the two values of T for which the ring is in limiting equilibrium. Now what is the difference between these two values of T? Sometimes the ring is going upward because there can be two directions for this ring. Sometimes the ring is sliding up, then if it is sliding up, the force of friction will be downward, and if it is sliding down, the force of friction will be upward. So in first case, let's suppose the ring is sliding up. Ring is about to move up. Now in this case, if we resolve all the forces parallel to the movement and perpendicular to the movement, we will have these two components. This component will be T cos 30 degree. This is horizontal component of the external force, and this component will be T sine 30. T sine 30. And I have told you so many times that the normal reaction is always perpendicular to the movement. You can see that the ring will be moving upward or downward. So the direction of R will be towards left side. And then there will be weight of the ring, which will be 2 times 10, 20 newtons. In first case, ring is about to move up, so the force of friction will be downward. Now we can see some, if you talk about the parallel forces or the horizontal forces, you have two forces, T cos 30, and that will be equal to R. So R will be equal to T cos 30. And if you talk about the perpendicular forces or the vertical forces, you have three forces. F plus 20 will be equal to T sine 30. F plus 20, that will be equal to T sine 30. So you can use this equation, this one. You know that F is basically mu R plus 20, and this will be equal to T sine 30, and mu is given, which is 0.24, and R can be placed from here. Mu is 0.24 and R is basically T cos 30 plus 20 is equal to T sine 30. So if you solve this equation, you will have T times 0.24 cos 30 minus T sine 30, that will be equal to negative 20, and T will become negative 20 divided by 0.24 cos 30 minus sine 30. If you find this for T using calculator, you will have negative 20 divided by 0.24 cos 30 minus sine 30. This will become 68.45, so you will have 68.5 newtons. So this is the first value of T in which the ring is about to move up. Now look at second case. In this case, the ring is about to move down. So in this case, this force of friction will be upward. Now you can see that the horizontal components will remain same, but there is a difference. There will be a difference in vertical components. You will have the equation for the perpendicular or vertical component, which will become F plus T sine 30. These are the forces which are upward, and for downward you have just one force, which will be 20 Newton. So now you will find the value of T using these two equations. And you know that this is basically mu r. This equation will be mu r is equal to T mu r plus T sine 30 is equal to 20. And you know that mu is 0.24 and r is T cos 30. So you will have T times 0.24 cos 30 plus T sine 30 is equal to 20. So for T you will have this expression 0.24 cos 30 plus sine 30. So if you solve this using calculator, T will become 28.3 newtons. This is the second possible value for T. Let's move to next question. All right, look at this question. Again, you have an inclined plane, and let's resolve all the forces parallel to the movement and perpendicular to the movement. Look at this diagram. First of all, you can have two components for this T. The horizontal component for this T will be T cos 20, and vertical component of the external force T will be T sine 20 plus the components of weight, which will be W sine theta, the parallel component of weight, and the perpendicular component of weight will be W cos theta, and this will be the normal reaction force, and there will be the coefficient of friction, which is 1/4. And you can see from the statement that the block is in limiting equilibrium. It means equilibrium is about to finish, and the object is about to move up the plane. Up the plane means the friction will be downward. So you can have two equations, one for the parallel forces and one for the vertical forces. First of all, let's form an equation for parallel forces. You have three parallel forces: F plus W sine theta, F plus W sine theta. This will be equal to T cos 20. And you know that W will be 25 newtons and theta is 30 degree. So if you simplify this equation, you will have mu r. Mu is 1/4 or 0.25. So you will have 0.25 r plus weight is 25 and angle is 30 degree. This will be 25 sine 30, and that will be equal to T cos 20. I am marking this equation 1. Now we will make an equation for the perpendicular forces. For perpendicular forces, you have three forces. Two forces are upward and one is downward. The upward forces are R plus T sine 20, and downward force is W cos theta. If you simplify this, you will have R plus T sine 20, and that will be equal to W is 25 cos 30 degree. This will be equation 2. So you have two equations with two variable. This is the equation in which you have two variable t and r, and it's a linear equation. And similarly, you have an equation in which you have r and t. You can simultaneously solve these two equations to find t and r. If you solve these two equations simultaneously, t will be 17.5 newtons. Now we are moving towards next question. All right, look at this question. You have some combination of forces, and you can see that you have three diagonal forces, and you will resolve all the diagonal forces horizontally or vertically. First of all, look at this force. The horizontal component will be 100 cos 30, and the vertical component will be 100 sin 30. Similarly, for this force F, the vertical component will be F sin alpha, as this force is making angle alpha with the horizontal, and the horizontal component will be F cos alpha. And look at this force. This will be the horizontal component 120 cos 60, and the vertical component will be 120 sin 60. Plus, you can see that the box has mass 40 kg, so its weight will be 400 newtons, which will be downward. So let's make an equation for the horizontal forces. This will be the equation for parallel or horizontal forces. You have some forces, and if you read the statement, that the resultant of three horizontal forces acting on the box is in the positive x direction and has magnitude 136 Newton. So if you sum up all the horizontal forces, this will give you 136 newtons. So you can see that summation Fx is basically 136, sum of all horizontal forces. And you can see that you have three horizontal forces, first, second, and third. And in the statement, it is given that the resultant of three horizontal forces is in positive x direction. It means that the object is moving towards positive x-axis. So these two forces will be positive as the object is moving towards positive x-axis, but this force will be negative. You will have equation 100 cos 30 plus 120 cos 60 minus f cos alpha is equal to 136. And if you simplify this, you will get f cos alpha is equal to 10.6. Mark this equation 1. Now, you can see in the statement that the object is moving horizontally. It means vertical forces will not have any effect. Vertically, the object will be in equilibrium. Vertically, the object will be in the state of equilibrium. You can also say that all downward forces will be equal to all upward forces. So if you talk about the perpendicular forces, summation Fy will be 0. So you can have an equation F sin alpha plus 100 sin 30, F sin alpha plus 100 sin 30 that will be equal to 120 sine 60. And if you simplify this, f sine alpha will be equal to 53.92. This is second equation. Now you can solve both equations simultaneously, and in this case this component weight will be cancelled with r, so no need to mention weight in the perpendicular component. All right, now you have these two equations. This is equation 1 and this is equation 2. If you divide these two equations, divide 1 and 2, you will have f sine alpha divided by f cos alpha, and that will be 53.92 divided by 10.6. So you will have tan alpha is equal to 53.92 divided by 10.6, and if you take tan inverse of this fraction, 53.92 divided by 10.6, this will give you 78.9 degrees. This will be the value for alpha. Now you are supposed to find f, so you can substitute this value of f over here or in equation 1. This will give you f is equal to 53.92 divided by sine alpha. Alpha is 78.9. So if you simplify this, you will get f is equal to 54.9 newtons. So this will be the value of f. Now look at part 2. It is given that the box is moving with the constant speed. You can see in the statement. And first of all, you are supposed to find the magnitude of the frictional force and then the coefficient of friction between the box and the floor. All right. Look at the box, and if you talk about the horizontal forces, because we will discuss only horizontal forces, these are the resultant of all forward forces, which is 136 Newton. We have seen from the statement that the resultant of all the horizontal forces is 136 Newton. Plus, as the object is moving forward, the frictional force will be backward. Plus, weight is, look at the weight, it is 400. Yes, the weight is 400 Newton, and this will be the value of r. Now, because the object is moving with constant speed, so the acceleration will be 0. You can apply Newton's second law here, which is F is equal to ma. You know that F is basically net force. Net force will be 136 minus F, and acceleration is 0. So the frictional force will be 136 Newton. Now you are supposed to find mu. You know that friction is basically mu r. So mu will be 136 divided by r. So you will have 136 divided by 400, which will be 0.34. So we have done all the concepts related to forces and equilibrium. And remember one thing, that in your 50 marks paper of mechanics, you will have 2 questions from this chapter, forces and equilibrium. We have done some practice questions regarding this topic. Now we will start new topic in our next video. Thank you so much. Assalamu alaikum.